Good morning, everyone. Let's have a small recap of what we have learned yesterday. Yesterday, we have gone through why frequency is to be maintained constant, and we have also seen different types of frequency regulation, isn't it? We have seen flat type, we have seen parallel type, we have seen flat tie line loading. And apart from that, in a two-area system, we have seen elective frequency control and tie line loading control. We have seen these things. Apart from that, we have discussed about a turbo generator. We have discussed about a steam generator, which consists of a speed governor for turbine, a generator, along with its load. So these are the components of turbo generator. And we have also seen that there will be two independent channels which are assumed in a turbo generator. One is PF channel, the other one is QV channel. When we are concentrating on PF channel, any changes in the active power will lead to change in the frequency. Any change in the reactive power will lead to change in the change in the voltage. So now our target is to regulate the frequency. If any change in power is there, let us suppose because of demand, you are supposed to overcome it by raising your generation or by lowering your generation. And you are supposed to make sure that F remains constant. Okay. So now for that, before going further, I think I have already told you about single area and the two area system, isn't it? So what do you mean by a single area system or a two area? So first of all, before going for that, I think I have skipped this part yesterday. So now today we will start with this. What do you mean by a single area and a two area system? What actually mean by a control area? And what are the components of turbo generator and how to model them? And how to develop an expression between active power and frequency. Okay. So now this is what we have learned. And we have also learned that this particular channel is slow, very slow, because of high time constraint. Because the machines are very heavy, so it will be very slowly operating, whereas these fast operating because of low time constraint. Okay. So which means that transients do happen in this control channel. It will be difficulty for us unless we have a high case on. Okay. So now, let's look back about, first of all, what do you mean by a control area? We'll start with the basic definition of a control area. A control area is nothing but a particular area which consists of large number of generators which do operate coherently. Okay. Which means that how to define the control area? An area which consists of a large number of generators. Okay, we will take that. It consists of number of generators acting as a coherent group, acting as coherent group. So what do you mean by coherent group? Which means that the coherent group means that all the machines share all the generators. Either they speed up or slow down in unison, which means that all they will behave in the similar fashion. This particular area, which consists of number of generators, all working in unison, is called as control area. Normally, in practice, control area refers to, let's see, in our, let us suppose, these are individual control area, single control area. This is also a single control area. AP state electricity board, Telangana state electricity board, Tamil Nadu state electricity board. In this particular area, control area, all the generators which do come under this Telangana power generation area, they will work in unison to maintain the same frequency. Okay. So this particular is called as control area. Now, if you take these two, it is called as a two areas. And these two control areas, they will be connected by a transmission line. This is called as a tie line. There may be number of tie lines for you. This is called as a two-area system. If we consider only one, it is called as a single area. If we consider multiple items, then it is called as a multiple area. Hope you have understood what you mean by control area. Okay. What is the purpose of maintaining a control area? Because we need to maintain the frequency constant. We need all the generators to undergo the same procedure, or at least similar procedure, in order to maintain a constant frequency in the premises of that particular area. For that thing, we will maintain a control area. We will call them as control area. Okay. Now, we will first of all consider a single control area. We will consider a single control area. Okay. So, in a single control area, okay. First of all, let us assume that there is only one. Assume that there is only one turbo generator, which means a steam generator. Okay. Supplying air load. So I am considering that there is only one generator which is supplying air load. So the important components are turbine, generator, load, and for this turbine there will be a speed. So these are the important components of a single turbo generator system. Okay. Now we will model step by step each of these components in the consecutive classes, and then we will try to model it completely by keeping all the elements together. Okay. First of all, today we will concentrate on developing a model for speed governor. Okay. So first of all, before going for this one, so what we are doing, we have defined single control. We have defined a control area, and we have understood what are the premises of a control area. Every electricity board is generally considered to be a single area, a control area. So we are confining ourselves to a single control area, which has a single turbo generator catering to a load. And we are developing the model for a single area system. So we are starting with the modeling of each of these components. So now, first of all, let me develop a mathematical model. Next, we can go with the control system model. Okay. Now, today's class, I'll be concentrating on modeling of speed governing system. What is the purpose of the speed governing system? It governs the speed of the turbine. Okay. Now, first of all, let me draw the structure or schematic diagram of the speed governing system. And next, let me explain the components. Then we can go to the model. Okay. First of all, let me draw the I hope you are able to see the picture now. I hope you can visualize this, the speed governance system. Okay. Now, see this one. This is called as a speed governing system, which controls the speed inlet to the turbine. Now, let's see how it is going to work. See, there are four important parts of your speed governing system. The first one is your speed changer. Okay, this is your speed changer. This is your flyball speed governor. This is called as your flyball speed governor. This concept is called as hydraulic amplifier, this entire thing. This is hydraulic amplifier. And this is A, B, C, D. If you can see, this is your this is a linkage mechanism. Okay. This is a linkage mechanism. A, B, C, D is a linkage mechanism, just like a wire type of thing, okay? A rod type of thing. So once again, the important components, the speed changer, the speed governor, the hydraulic amplifier, and the linkage mechanism. Now let me explain how this is going to work. Okay, before going for that, I'll take this direction. Okay. So now, let me explain each and every of these components. Now, if you carefully see, A, B, C, D, this is going to be a linkage mechanism, which will be very stiff, assuming that B and D are the pivots, which means it is just like a seesaw. B is the pivot, A and C, they will be moving like this. Okay, just if you take a, yeah. Now, this is like, okay, pivoted at B. A and C can move, but B is pivoted, okay. Similarly, C and D, C, D, E, this is another linkage. It is pivoted at D. So if C moves, E moves. If C, E moves, E moves. So this is the mechanism. A, B, C, D is the linkage mechanism which is pivoted at B and D. Okay, which is pivoted at B and D. See the lengths also I have mentioned for you, L1, L2, L3, and L4. These are the lengths of the linkages. Now, this is the flyball speed gauge. So what does it do, flyball speed gauge? This is the heart of your entire system. Now, how this is going to work? This flyball speed governor, it senses changes in the frequency. It senses changes in the frequency. How does it sense a change in the frequency? It senses the change in speed, thereby sensing the change in frequency. Which means if speed is increased, frequency is increased, isn't it? So if the speed is increased, if N increases, which means F increases, or vice versa. If N increases or N increases, then automatically what happens? The fly balls move outside. See, there are two fly balls here. This is a fly ball. Okay, this is a fly. As the speed increases, these fly balls they move outside. If they move outside, this is a spring type of mechanism. So this will lead to point B coming down. Okay, this leads to point B coming down. So whenever there is an increase in the speed, whenever there is an increase in the frequency, let us suppose there is some drop in the load. If demand is decreased, automatically what happens? The frequency will increase. It is a vice versa. It is a inverse relationship, right? If frequency increase, then automatically speed is supposed to be increased. If speed increases, The fly balls, they move outside, bringing the point B down. Okay, so this is the concept which affects the movement at B. Now, another one, the speed changes. If you can see, there is a speed changer here. The speed changer is a manual control. So let us suppose if I want to control this mechanism manually, so I can either raise this one or I can lower this one. Let us suppose if I want to increase the speed, I will, see, this is the raise symbol, right? If I want to raise the speed, I will just push it down. If I want to lower the speed, I will just pull it down. Why it is being done like this, I will show you, okay, in the coming portion. This is a manual control. If I want to manually vary the speed, either increase or decrease, then automatically I can adjust this linkage mechanism. Now this one also adjusts the linkage mechanism, but automatically. Both these things, they are controlling this linkage mechanism. Now you might be getting a question. So why controlling the linkage mechanism? We should go for a frequency regulation, isn't it? Now I'm coming to that part itself. Once again, a small repetition. This is manual control of linkage mechanism for variation of speed. This is automatic control of linkage mechanism for control of speed, right? Now, sir, what is this linkage control? Why it is doing here? What is the scheme? Now, I'm coming to this point. This is called as an hydraulic amplifier. Okay, see, there are two pistons here. This is pilot valve, and this is main valve, and this is your main valve. Now, if you carefully see, this is your main valve. I can write it as main piston. Okay. Okay. This is main piston. I can adjust this one. If I can adjust this one, this will block the steam input to your turbine. Hydraulic amplifier, why I'm employing this? This is a very powerful tool. Hydraulic amplifier just amplifies the mechanical action. Just your sensor signal will be very, very of low strength. You are supposed to convert this low strength signal to high strength signal because you need to push this valve, which will be having high moment of inertia. Whenever you do have a low signal, to convert into a high energy signal, what you will be doing? You will be going with this hydraulic amplifier. This converts your normal change in speed signal. Just with this thing, you are controlling the linkage, right? From this linkage changes to, it will just control the steam. Now, how to control this main piston? Now, see here, there is a high pressure oil coming into here. See, if you carefully see, the high pressure oil comes into this chamber and flows into this chamber. Okay. Now, if you carefully see, this is the high pressure oil which is coming from here. Now, if you see, there are two vents here. This is one vent, this is another vent. If I push this one up, if I push this pilot valve up, then the high steam valve enters into this direction and it pushes the main piston down. It pushes the main piston down. So what will happen? This comes down, so more steam input will be moving into the turbine. So once again, I'm repeating. High pressure oil coming. If I open this valve, ఇది రెండు ఉన్నాయి కదా, దీన్ని పైకి జరిపాను అనుకున్నాం. ఈ వాల్వ్ ఓపెన్ అవుతుంది. ఈ వాల్వ్ ఓపెన్ అయితే ఇది కిందికి వస్తుంది. ఇది కిందికి వచ్చిందంటే స్టీమ్ ఇన్పుట్ పెరుగుతుంది. Now, if I push this one down, what happens? The valve opens this one. So here, the steam will be, the high pressure oil will be coming in this way. It pushes the piston up, it goes up, thereby blocking the steam. Understood? So it all lies how you are moving this pilot valve. If you move this pilot valve up, steam output will increase. If you move this pilot valve down, steam output will decrease. Okay. So it's all there lying in this movement of pilot valve and how it is being moved with the help of these. Now, we will take a sample example. Okay. Now, let us suppose if I have sensed some speed change. What I have sensed is, I have sensed some speed change. Suddenly, there was a drop in load. Since there was a drop in load, the speed suddenly increased. So what I should do? The speed is suddenly increased. I will write it down, please. There was a drop in speed. There was a drop in power demand. So which led to increase in speed. If increase in speed is there, then automatically frequency increases, isn't it? So since the speed is increased, speed has increased. What will happen? The fly balls move outwards. If fly ball move outwards, what will happen? B point decreases. Now it is just like a scale, isn't it? It is just like a scale, isn't it? Now because of this, if B point gets down, what will happen to this C? C also is becoming down, isn't it? ఈ మొత్తం సీసానే కిందికి చేస్తాం, బి పాయింట్ నే కిందికి అట్లా కాకుండా ఏ పాయింట్ ఒకదాన్ని కిందికి జరిపింటే సి పాయింట్ ఇట్ వుడ్ హ్యావ్ గోన్ అప్. బట్ వాట్ ఐఎమ్ డూయింగ్, ఐఎమ్ జస్ట్ బ్రింగింగ్ డౌన్ బి పాయింట్. సో వాట్ విల్ హ్యాపన్, సి పాయింట్ ఆల్సో విల్ కమ్ డౌన్. నౌ దిస్ ఇస్ అనదర్ వన్. సి పాయింట్ హ్యాస్ డిక్రీజ్. సో వాట్ విల్ ఇట్ డూ? సో వాట్ విల్ ఇట్ డూ? It will affect this E1. It will affect this. If E point goes up, what will happen? Steam output will decreases. If steam output decreases, what will happen? PG decreases. Now, see. If demand decreases, what you are doing finally? You are decreasing the If demand decreases, what is finally what you are doing? You are decreasing the generation. Now have you understood how this works? Now, we will take one more thing, okay? Now, I will take that. If speed increases, demand increases, speed will drop, isn't it? If speed drops, what will happen? These will become closer. What will happen? This B point will raise. If B point raises, what will happen? C point will also raise, isn't it? If C point raises, what will happen to E? E point will decrease. If E point decreases, more steam input will go. Steam will increase. If steam increases, more generation will be there. See, since PD has increased, it has increased PG. Okay. This job, steam input to PG, it will be done by turbine and generator. But here, up to in this concept, we are looking into only this one. Only up to this. This was a change in thought. Now let us suppose I am going for one more. Okay. I want to manually increase my generation. I want to manually increase I don't have any control of PD. Now I want to increase my speed. If I want to increase my speed, what should I do? Speed demand is constant. If I want to increase speed, what I must do? I must increase PG, isn't it? Let's see how I am going to achieve it. If I want to increase the speed, say, if I want to raise the speed, what I am supposed to do? I am supposed to push down A. Isn't it? If I want to raise the speed, I want to push down A. Say now. Now this one will act as a seesaw. Because if B, I am not changing B. A is decreased. So automatically what will happen to C? C will increase. If C increases, what will happen to E? E will decrease. If E decreases, what will happen? Steam output will increase. Thereby, PG increases. This is what the target, PG increases, and I have achieved the target of increasing my PG. Hope you have understood how this mechanism is going to work. So once again, this is the manual control of speed changer. This is automatic control, fly ball speed governor. This is hydraulic amplifier. Just amplifies just simple signal to a powerful mechanical signal, and this is a linkage mechanism. And the linkage mechanism is the key one, to operate a field governance system. Okay. Hope you have understood this one. Now, let me explain the mathematical modeling of this one. I'll quickly, if you permit me, I will. So, hope you have understood this concept. Okay. Now, before wiping this thing, I want to show you, before moving on to mathematical modeling, I want you to remember one particular thing. How these linkage points are interlinked. How these, now if you carefully see, point A is manually controlled, isn't it? Point B is automatic control. How? Because of change in power demand. This is power command, this is power demand. PC, PD. Okay, because of these two things. This is a manual control, this is an automatic control. Point C is a function of both A and B, isn't it? A vary aina, C vary. B vary aina, C vary. See now. If A varies, C will vary. Or if B comes down or moves up also, C point is going to vary. Okay. So C is a function of A and B. A కిందికి వచ్చినట్టు C ఏమవుతుందిరా పైకి వెళ్తుంది. So it is in a inverse position, inversely proportional to A position. Whereas B కిందికి వచ్చినట్టు C కూడా కిందికి వస్తుంది, B పైకి వచ్చినట్టు C కూడా పైకి. So C is in that position. Next is, the next one is D. D has also no control, it just depends upon your C and D. D is a function of C and E because it is just the middle point. Okay. And the other one is E. E is a function of only D. Assuming that D and D combinedly work together as an amplifier. Okay. This is what my assumption. D and D combinedly work together. I'm assuming that D and E are interrelated. Apart from that, D is a function of C. Because even though I have explained that because of C there is an action on E, this is mainly because of this hydraulic amplifier. So D performs the action of moving E. Okay. So that's why what I have done. D is a function of both C and E, and E is a function of D. I hope you do remember these points before we move on to the mathematical modeling. Okay. So now I am going to arrange this entire thing. See the length L1, L2, L3, L. Hope you do remember this figure before moving on to mathematical modeling. Yeah. Now, yeah. I'm coming back to mathematical modeling of speed governing system. Okay. So in this one, we will start with movements. At, first of all, I'll start with the movement. Okay. I'll assume that the movement, the change in movement, assume change in movement at A, B, C, D, E, B, delta YA, delta YB, delta YC, delta YD, and delta Y. The change in YE, a change in the position of E will affect my turbine speed, isn't it? So now, first of all, we will move on to step 1, delta YA. Delta YA is because of your manual control, isn't it? It is purely because of your manual control, and it is dependent on your change for command change. This is a manual command, right? So that's fine. I'm just taking this one. Okay. This is delta value. I'm just taking this constant. Kc is some constant. YB. YB position is completely, how it is that? It is completely because of your automatic control, because of your frequency change, isn't it? It is because of your frequency change, right? So I'll take it as some K2 dash. Why I have taken K2 dash, I'll explain it to you later. I'm taking it as K2 dash. Okay, some constant. Now, delta YT is and delta YT, isn't it? It depends upon both delta YA and also delta YT. Right. L1 and L2 are the two lines. Now, how it is going to be affected? As you all know the mathematics. Yeah. A ki inverse lo untundi nanu, B ki direct untundi kabatti I am taking minus L1 by L2 into delta YA plus L1 plus L2 by L2 into delta Y. Right. Okay. Sure. L2 by L1. Okay. L2 by. So this is Kc into delta Pc. Yeah. So నేను మొత్తానికి K1 అనుకుంటున్నారా? K1 delta Pc ప్లస్ దీని మొత్తాన్ని నేను K2 అనుకుంటున్నాను. ఇదంతా K1 అనుకుంటాను. దీని మొత్తాన్ని K2 K2 delta. Okay. So this is my delta P. Okay. I'll take that mine. Okay. This is mine. Okay. Now, moving on to delta YT. Moving on to delta YT. How it is? Moving on to delta Y, isn't it? So this is L3, this is L4. Assuming that D moment is dependent on both C and D. So how it is? Okay. L4 by L3 plus L4 into delta YC plus opposite L3 by L3 plus L4 into delta Y. Sorry. Delta Y. This is the moment at point number D. Now I am going to take these constants as K3. I will consider this one as K3. You don't need to remember all these things. You can directly keep it as K3 delta YC plus K4 delta Y. Now coming to the last point, hydraulic amplifier, I assume that only the point D is provoking point E in order to have a large mechanical action. It is an amplifier, right? So I'll assume that delta YE is proportional to integral of delta Y. Okay, so that's why I'll take a constant of K5 since it is inverse proportion of delta Y. If I take it in time domain, it is a time domain. Okay, it's not, this is a time domain. D. Okay. This has been taken just because of the manipulation of assuming that it is a hydraulic amplifying action. So these are the movements in 1, 2, 3, 4, and 5. A point just because of the manual control, B point because of the frequency, C point because of both A and B, D point is assumed because of C and D, and E point is exclusively, even though C is having its own impact, I am assuming that since it is an amplifier, only the signal, the pilot valve D is controlling E. Okay. So I'll keep it this one like this, and I'll continue the remaining in the next class. Thank you for joining. Thank you all. We'll meet again. Okay.